Subtraction is really addition. First, let's do a quick review of additive inverses on the number line. The positive numbers are to the right of the zero, and the negative numbers are to the left of the zero. Each number represents an absolute value distance from the origin of zero, and each number has an opposite that is the same distance from zero in the opposite direction. A number and its opposite are called additive inverses. Here's a very important fact to remember about additive inverses. When a number is added to its additive inverse, or opposite, the result is always zero. This rule is true because positive and negative signs refer to direction on the number line. Positive numbers count to the right on the number line because they show increasing value, and negative numbers count to the left on the number line because they show decreasing value. So, what does this have to do with algebra and using the commutative property to subtract? The concept of additive inverses allows you to understand this phrase. Subtracting is the same as adding the opposite of a number. Subtraction is really a form of addition. Sounds crazy, but it can be proved with a simple example. What is 5 minus 5? Start with what you know. You've known for years that subtracting 5 from 5 gives you 0. This is proven on the number line when you start at positive 5 and subtract, or decrease the value by 5 units, ending at 0. So, how can you find the same answer using the additive inverse rule? There are two steps you use to change subtraction to add the opposite. First, change the subtraction symbol to an addition symbol. Second, change the number that follows to its additive inverse, or the opposite of the number. In the example problem, 5 minus 5, what is the additive inverse of the 5 that comes after the subtraction symbol? The additive inverse, or opposite of 5, is negative 5. If you follow the two steps for the additive inverse rule, the problem changes to look like this. 5 plus negative 5. What is the answer whenever opposite numbers are added? Of course, the answer is 0. You've just shown that 5 minus 5 can be rewritten as 5 plus negative 5. Let's look at another example that doesn't use exact additive inverses. What is 12 minus 4? The image shows that 12 minus 4 equals 12 plus negative 4. But you need to know how to actually find the answer when you change a subtraction problem into an add the opposite problem. The key is to see the positive and negative signs as directions. In this example, 12 means you count 12 units toward the right of 0 because positive means to increase. The next part of the expression shows a negative number. Negative means to decrease, so the negative 4 shows that you need to count toward the left. If you count 4 units toward the left from 12, you arrive at the number 8. Vertical number lines are also useful for picturing how to find answers when you have positive and negative numbers. In this example, the expression starts with a smaller number and subtracts a larger number. What is 3 minus 5? Up to now, you would have said this problem can't be solved. But with subtraction, as adding the opposite, it can. This time, you started on the positive part at 3, but then added negative 5. When you count down 5 units from 3, the value becomes negative or less than 0. What happens if you start with a negative number and then subtract a number? Let's look at this one as a word problem. Trey's thermometer showed a temperature of negative 5 degrees Fahrenheit at 4 p.m. 3 hours later, the temperature was 6 degrees lower. You know that lower means less and signals you to subtract. So the problem is negative 5 minus 6. The idea that subtraction is the same as adding the opposite might seem pretty shocking, but it's an idea and a tool that will be very useful when working with expressions and equations in algebra.